Hey, how y'all doing? I'm doing another audio study guide here for the EPA refrigerant certification tests. For those who may want to study some notes, while they might be working or something like that. Like that's the whole reason I did this myself. I wanted to study while I am at work with my headphones on, something like that, where I can just study in peace. But I might not have, my hands might be busy to do certain things, like on the papers. So here we go. Let's start off here. So I'm gonna read some information and just take note of it for memorization. Technicians maintaining, servicing, repairing, or disposing of high pressure or very high pressure appliances, except small appliances and MVACs, must be certified either as a universal technician or as a type 2 technician. So keep that in mind. That's technicians that are repairing and disposing of high pressure or very high pressure appliances, except small appliances and MVAC, must be certified as either a universal technician or a type 2. Okay, after the installation of any type of system, the unit should be pressurized with nitrogen and leak checked. So after the installation of any type of system, the unit should be pressurized with nitrogen and leak checked. Okay, nitrogen is an inert gas. So remember that nitrogen is an inert gas. In order to determine the general area of a leak, technicians should use a electronic ultrasonic leak detector. So let me repeat that again. In order to determine the general area of a leak, technicians should use a electronic or ultrasonic leak detector. After locating the general area of a leak, soap bubbles are used to pinpoint it. So soap bubbles can be used to pinpoint the leak after you find the general area, that is. Let's see. A refrigeration unit using an open compressor that has not been used in several months is likely to leak from the rotating shaft seal. So repeat that again. A refrigeration unit using an open compressor that has not been used in several months is likely to leak from the rotating shaft seal. During a visual inspection of any type of system, traces of oil are an indicator of a refrigerant leak. So during a visual inspection of any type of system, traces of oil are indications of a refrigerant leak. For what refrigerant is an equipment room refrigerant monitor required under the ASHRAE standard 15? And that answer is R123. So number R123, you got to have that room monitor. That monitor, I believe for the I believe it's for oxygen level. I believe. So for what the question is, what refrigerant is an equipment room refrigerant monitor required under the ASHRAE standard 15? And that answer is R123. So R123. Okay, which component is not part of the low side of the system? That is the receiver. Oh, you know what? Matter of fact, this ain't something totally different here. So keep that in mind too. Keep that in mind. The receiver is not part of the low component. I'm glad I did read this too. The receiver is not a component of the low side system, because see, I remember I was in class too. I thought the same thing. I thought the receiver is part of the low side because it has the liquid in it, right? You think of the liquid form of the refrigerant, you think of the low side, the cooling and the low side. But actually, the receiver, remember, is before the metering device. The receiver comes after the evaporator. I mean, after the condenser, but before the metering device. Remember, the metering device separates the high side from the low side, but the receiver comes before the metering device. So it's on the high side. So keep that in mind. Just remember that the receiver is on the high side, not the low side. Even though it deals with the liquid refrigerant, it's on the high side. Okay. To change the compressor or a system containing 40 pounds of R500 using a recycling machine that was manufactured after November 15th, 1993, you must isolate the compressor, then evacuate the isolated section of the system to blank inches of vacuum and hold. If the system pressure does not rise, remove the compressor. So the answer to that is 10. So I'm going to read it with the answers now. To change the compressor on a system containing 40 pounds of R500 using a recycling machine that was manufactured after November 15th, 1993, you must isolate the compressor, then evacuate the isolated section of the system to 10 inches of vacuum and hold. If the system pressure does not rise, remove the compressor. Okay. I'm going to read that one more time so it can kind of absorb all that in. To change the compressor on a system containing 40 pounds of R500 using a recycling machine that was manufactured after November 15, 1993, you must isolate the compressor, then evacuate the isolated section of the system to 10 inches of vacuum and hold. If the system pressure does not rise, remove the compressor. Okay, the back seating of a suction shutoff valve will close the gauge port. I'll say that again. The back seating of a suction shutoff valve will close the gauge port. When charging an R410A system that uses a water-cooled condenser, you must first charge with vapor to a pressure of at least 120 psig before switching to liquid. So when charging a 410A system that uses water-cooled condenser, you must first charge with vapor to a pressure of at least 120 psig before switching to liquid. Okay, refrigerant leaves the receiver of a system as a high-pressure liquid. Remember I told you that's the high side, remember? Refrigerant leaves the receiver of a system as a high-pressure liquid. Okay, the evaporation temperature of R410A at 100 psig is about 30 degrees Fahrenheit. So the evaporation temperature of R410A at 100 psig is about 30 degrees Fahrenheit. When using recovery or recycling equipment that was manufactured after November 15, 1993, you must evacuate the system containing more than 200 pounds of R12 to 15 inches of mercury vacuum before making a major repair. Okay, so when using recovery or recycling equipment that was manufactured after November 15, 1993, you must evacuate the system containing more than 200 pounds of R12 to 15 inches of mercury vacuum before making a major repair. And I believe if it's before than November 15th, 1993, it would have to be 4. In a refrigerant system with a TXV or other types of throttling device, The component directly following the condenser is the receiver. In a refrigerant system, the component directly following the evaporator is the accumulator. So that's another thing I wanted to talk about too, that I didn't get to in the last video too. So in the refrigerant system, like the previous statement was, in a refrigerant system with a TXV or other type of throttling device, the component directly following the condenser is the receiver. In a refrigerant system, the component directly following the evaporator is the, here it says the accumulator. That's if you have, that accumulator. But with the accumulator, it's kind of similar to the receiver in some ways, but it like collects any form of liquid refrigerant coming out the evaporator before it gets to the compressor, for what I understand. Because remember, the liquid refrigerant getting into the compressor could cause damage to the compressor, because the compressor takes in the refrigerant in a vapor state. Because the refrigerant is supposed to become vapor as it enters as it leaves the evaporator. So as it leaves the evaporator to go to the compressor, it should be in a vapor state. But let's say refrigerant, some of it's still in a liquid state, it goes into the accumulator. Okay, when evacuating a system that uses a large vacuum pump could cause trapped water to freeze. So remember that when evacuating a system that uses a large vacuum pump could cause trapped water to freeze. When a refrigerant trace gas becomes absolutely necessary, which of the available refrigerants should be used to identify a leak? And they say that is R22. So when a refrigerant trace gas becomes absolutely necessary, which of the available refrigerants should be used to identify a leak? R22. Okay, the primary water source for cooling the condenser of a water cool recovery unit is a local municipal water supply. So the primary water source for cooling the condenser of a water cool recovery unit is the local municipal water supply. Okay, while Fortinet is a high pressure refrigerant, it can be stored in the back of your service van as long as the temperature inside the vehicle does not exceed 125 degrees Fahrenheit. This is the same guidance given for R22 and other common refrigerants. So I'm going to repeat that again. While Fortinet is a high pressure refrigerant, it can be stored in the back of your service van as long as the temperature inside the vehicle does not exceed 125 degrees Fahrenheit. This is the same guidance given for R22 and other common refrigerants. The refrigerant pressure inside an R410A unit, which is at room temperature, 72 degrees Fahrenheit, is not operating, is approximately 210 psigs. So I'm going to say that again. The refrigerant pressure inside an 410A unit, which is at room temperature, 72 degrees Fahrenheit, is and not operating is approximately 210 psig. Say that one more time. The refrigerant pressure inside a 410A unit, which is at room temperature, 72 degrees Fahrenheit, and not operating is approximately 210 psig. Okay. The method to charge a system that has a normal charge of 80 pounds is to charge with liquid through the liquid line service valve. So the method to charge a system that has a normal charge of 80 pounds is to charge with liquid through the liquid service valve. Every air conditioner or refrigerant system should be protected by a pressure relief device. Every air conditioner or refrigerant system should be protected by a pressure relief device. To change the compressor on a system containing R410A, you must isolate the compressor, Then evacuate the isolated section of the system to atmospheric pressure and hold. If the system pressure does not rise, remove the compressor. So we went over that before. To change a compressor on a system containing R410A, you must isolate the compressor, then evacuate the isolated section of the system to atmospheric pressure and hold. If the system pressure does not rise, remove the compressor. Okay, hold up. Okay, non-condensables will cause higher discharge pressure. Non-condensables will cause higher discharge pressures. Where there is a risk of freezing, liquid charging of an R12 refrigerant system should begin with vapor from a vacuum level to a pressure of approximately 33 psig, followed by a liquid charge through the liquid line service valve. So I'm going to repeat that again. Where the risk of freezing, liquid charging of an R12 refrigerant system should begin with vapor from a vacuum level to a pressure of approximately 33 psigs, followed by a liquid charge through the liquid line service valve. Where there's a risk of freezing, liquid charging of an R12 refrigerant system, you should begin with the vapor from a vacuum level pressure of approximately 33 psig, followed by a liquid charge through the liquid line service valve, as we just said. Okay, ASHRAE standard 15. So ASHRAE standard 15 requires a refrigerant sensor that will sound an alarm and automatically start a ventilation system in occupied equipment rooms where refrigerant from a leak will concentrate. So that's the ASHRAE standard 15 requires a refrigerant sensor that will sound an alarm and automatically start a ventilation system in occupied equipment rooms where refrigerant from a leak will concentrate. Remember we was talking about that refrigerant R123, remember? Okay, refrigerant R12 and R11 and R134A are categorized as A1. So refrigerant CFC 12, CFC 11, and HFC 134A are categorized as A1. Okay, all refrigerant systems must be protected by a pressure relief valve, which must not be installed in series. Okay, all refrigerant systems must be protected by a pressure relief valve, which must not be installed in series. Never energize a reciprocating compressor if the discharge service valve is closed. Never energize a reciprocating compressor if the discharge service valve is closed. Okay, R14A requires a high pressure manifold gauge and hole set. They must have a 4,000 psig burst pressure and 800 psig working pressure. For R14A requires a high pressure manifold gauge and hole set. They must have a 4,000 psig burst pressure and 800 psig working pressure. The evaporation temperature of R134A at 0 psig is negative 15 degrees Fahrenheit. So the evaporation temperature of R134A at 0 psigs is negative 15 Fahrenheit. The filter dryer should be replaced anytime the system is open for servicing. The filter dryer should be replaced anytime the system is open for servicing. Okay, detecting a strong odor during the recovery process indicates a compressor burnout may have occurred. When recovering refrigerant from a system that experienced a compressor burnout, watch for signs of contamination in the oil. So when recovering refrigerant from a system that experienced a compressor burnout, watch for signs of contamination in the oil. A crankcase heater is often used to prevent refrigerant from migrating to the oil during periods of low ambient temperature. A crankcase heater is often used to prevent refrigerant from migrating to the oil during periods of low ambient temperature. Okay, and if refrigerant in the oil will cause oil foaming at startup. So refrigerant in the oil will cause oil foaming at startup. Okay, when evacuating a vapor compression system, the vacuum pump should be capable of pulling 500 microns, which is 29.90 inches of mercury of vacuum. So when evacuating a vapor compression system, the vacuum pump should be capable of pulling 500 microns, which is 29.90 inches mercury of vacuum. Okay, microns. We're talking about microns now. The more accurate preferred method of measuring deep vacuum is in microns, as I said before. A hermetic compressor motor winding could be damaged if energized when under a deep vacuum. So a hermetic compressor motor windings could be damaged if energized when under a deep vacuum. The use of a large vacuum pump could cause trapped water to freeze. During evacuation of a system with large amounts of water, it may be necessary to increase pressure by introducing nitrogen to counteract freezing. Okay, during evacuation of a system with large amounts of water, it may be necessary to increase pressure by introducing nitrogen to counteract freezing. The source of most non-condensables is air. The source of most non-condensables is air. This is why the filter dryer should be replaced anytime the system is open for servicing, because the source of most non-condensables is air. That's another thing I want to point out too. Okay, let's see. For R22 at 40 degrees Fahrenheit, the pressure is 68.6. So the pressure is 68.6, and the pressure for that we talk about 40 degrees Fahrenheit. So at 40 degrees, and for 410A, the pressure is 118.9 at 40 degrees Fahrenheit. It'd be 118.9 for 410A. So 410A's pressure would be 118.9 at 40 degrees, while R22 would be 68.6 at 40 degrees. Now, when it comes to freezing, remember they like to use we're kind of phasing out the R12s, so they're kind of moving into the R134A, which is an HFC. At 0 degrees, at 0 degrees Fahrenheit, the pressure for R134A will be 6.5. So remember that 6.5 when it's at 0 degrees Fahrenheit. Understand? 0 degrees Fahrenheit. You get 6.5 for pressure. And then as you move that, the temperature down even more, like you get into -6 degrees, -6 degrees Fahrenheit, you might have here is 3.7 pressure for R134A. But just keep in mind, 0 degrees Fahrenheit for the fridge will have 6.5 pressure for 134A. Let's go back to that 40 degrees temperature again. Repeat that again. For the R22, we have at 40 degrees temperature, at 40 degrees Fahrenheit, we have 68.6 pressure for R22. For the 410A, the pressure will be 118.9. Okay. Okay, back to these other notes here. System-dependent recovery equipment cannot be used on appliances containing more than 15 pounds of refrigerant. So system-dependent. Remember, system-dependent meaning they use their own compressor to remove the refrigerant, to recover the refrigerant. Excuse me. It cannot be used on appliances containing more than 15 pounds of refrigerant. So don't go using that on 200 pound refrigerant machines or something like that. Okay, now under the EPA regulations, a major repair means any maintenance, service, or repairs involving removal of any of all the following components: the compressor, the condenser, the evaporator, or an auxiliary heat exchanger. So under EPA regulations, a major repair means any maintenance, service, or repairs involving removal of any of the following components: the compressor, the condenser, the evaporator, or the auxiliary heat exchanger. Filter dryers will remove moisture from the refrigerant in a system, but there is a limit to their capacity. Filter dryers will remove moisture from the refrigerant in a system, but there is a limit to their capacity. Some filter dryers have a moisture indicating sight glass. Some filter dryers have a moisture indicating sight glass. When the sight glass changes color, the system contains excessive moisture. When a sight glass changes colors, the system contains excessive moisture. When a system contains excessive moisture, it needs to be evacuated. When a system contains excessive moisture, it needs to be evacuated. Okay. When units have a receiver storage tank, the condenser is below the receiver. Remove refrigerant from the condenser outlet. Okay, let me read that again. When the unit has a receiver storage tank and the condenser is below the receiver, remove refrigerant from the condenser outlet. So when the unit has a receiver storage tank and the condenser is below the receiver, remove the refrigerant from the condenser outlet. Okay. On a unit that has a receiver storage tank and the condenser is on the roof with an evaporator on the first floor, recovery should begin from the liquid line entering the evaporator. On a unit that has a receiver storage tank and the condenser is on the roof with the evaporator on the first floor, recovery should begin from the liquid line entering the evaporator. After recovery, refrigerant may be returned to an appliance from which it was removed, or to another appliance owned by the same person without being recycled or reclaimed. The exception is the MVAC-like appliances. Let's repeat that again. After recovery, refrigerant may be returned to appliance from which it was removed, or to another appliance owned by the same person without being recycled or reclaimed. The exception is the MVAC like appliances. The technician should always evacuate and empty recovery cylinders before transferring refrigerant to the cylinder. So the technician must always evacuate an empty recovery cylinder before transferring refrigerant to the cylinder. Quick couplers, self-sealing hoses, or hand valves should be used as low-loss fittings to minimize refrigerant release when hoses are connected and disconnected. So quick couplers, self-sealing hoses, or hand valves should be used as low-loss fittings to minimize refrigerant release when the hoses are connected and disconnected. Appropriate recovery equipment has been certified by EPA-approved laboratories, UL or ETL, to meet or exceed the ARI standard. So the appropriate recovery equipment has been certified by EPA-approved laboratories, UL or ETL, to meet or exceed the ARI standards. Okay, required recovery levels in inches of mercury. Other high pressure appliances or isolated components of such normally containing more than 200 pounds of refrigerant equipment before 11/15/1993 would have to be 4 inches of mercury, and after 1993, that 1993 November 15th would be 15 inches of mercury. Remember, 15 inches of mercury after the November 15th, 1993, and 4 inches of mercury before that date. And remember, we're not confusing this date of 11/15/1993 with the 11/15/1995, which is when they banned what was that they banned the venting of HFCs into the atmosphere. Okay, now let's see here. Pardon me, I'm doing this from my car actually. Okay, now required recovery levels in inches of mercury. Very high pressure appliances equipment before 11/15/1993 and after 11/15/1993. So this is now, we still talk about the required recovery levels in inches of mercury, but this time we talk about very high pressure appliances. So for very high pressure appliances, the required recovery levels in inches of mercury for both will have to be 0. For 0 before, 0 after. For very high pressure appliances. The last one we was talking about other high pressure appliances or isolated components of such normally containing more than 200 pounds of refrigerant. But this time we're talking about this very high pressure appliances. After reaching the desired vacuum, the technician should wait a few minutes to see if the system pressure rises, which would indicate there is still refrigerant in liquid form or in the oil. So after reaching the desired vacuum, the technician should wait a few minutes to see if the system pressure rises, which would indicate there is still refrigerant in liquid form or in the oil. Okay. And you know, 0 psig is the atmospheric pressure. So 0 psig is the atmospheric pressure. Okay. Appliances can be evacuated to atmospheric pressure if leaks make evacuation to the prescribed level unattainable. So appliances can be evacuated to atmospheric pressure if leaks make evacuation to the prescribed level unattainable. Say that one more time. Appliances can be evacuated to atmospheric pressure if leaks make evacuation to the prescribed level unattainable. The technician must isolate a parallel compressor system in order to recover refrigerant. So the technician must isolate a parallel compressor system in order to recover refrigerant. Failure to isolate a parallel compressor system will cause an open equalization connection that will prevent refrigerant recovery. So failure to isolate a parallel compressor system will cause an open equalization connection that will prevent refrigerant recovery. System-dependent recovery equipment cannot be used on appliances containing more than 15 pounds of refrigerant, as we said before. Okay. Refrigerant recovery and or recycling equipment manufactured after November 15, 1993 must be certified and labeled by an EPA approved equipment testing organization to meet EPA standards, meaning a third party that's approved by the EPA. That's why they're on the test. So it has to be a third party approved by the EPA. So repeat that again. Refrigerant recovery or recycling equipment manufactured after November 15, 1993 must be certified and labeled by EPA approved equipment testing organizations to meet EPA standards. Refrigerant. Hold up. So okay, now we're talking about the required recovery levels again of inches of mercury. R22 appliances or isolated components of such normally containing less than 200 pounds of refrigerant equipment before 11/15/93 and after 11/15/93 both will be 0, 0. So 0 inches of mercury before and 0 inches of mercury after. So we're talking about R22 appliances or isolated components of such normally containing less than 200 pounds of refrigerant. Okay, now this now talking about the same application of R22 and the isolated component of such normally containing more now than 200 pounds of refrigerant before or after the 11/15/93. So before it would have to have been 4 inches of mercury, but after the 11/15/93 it has to be 10 inches of mercury. This is R22 appliances or isolated components of such normally containing more than 200 pounds of refrigerant. So if it was less than 200 pounds, it had to be 0 inches of mercury. But if it's more than 200 pounds, it has to be 4 before 11/15/93 and 10 after 11/15/93. There's another one of these questions regarding recovery levels of inches of mercury. Okay, other high-level pressure appliances or isolated components of such normally containing less than 200 pounds of refrigerant. So other high-pressure appliances or isolated components of such normally containing less than 200 pounds of refrigerant equipment. So before 11/15/93, it would have been 4 inches of mercury. And after 11/15/93, it will be 10. So keep that in mind. To differentiate that one from the same statement I did with the R22 with less than 200 degrees, less than 200 pounds of refrigerant. We said that was 0, 0. But with this one here, it says other high pressure appliances or isolated components of such normally containing less than 200 pounds of refrigerant. Now, this one was 4 before and 10 after. So keep that in mind, not to be confused by that. Okay. Technicians working with multiple refrigerants before recovering or recycling a different refrigerant must purge the recovery recyclable equipment by recovering as much of the first refrigerant as possible change the filter, and evacuate. Exceptions: technicians working with R134A. So technicians working with multiple refrigerants before recovering and or recycling a different refrigerant must purge the recovery recyclable equipment by recovering as much of the first refrigerant as possible. Change the filter and evacuate. The exception: technicians working with R134A. Recovering refrigerant in the vapor phase will minimize the loss of oil. So remember that recovering refrigerant in the vapor phase will minimize the loss of oil. Okay, recovering refrigerant in the liquid phase can reduce recovery time. So recovering refrigerant in the liquid phase can reduce recovery time, but recovering refrigerant in the vapor phase will minimize oil loss. So the liquid phase seems to be quicker, while the vapor phase minimizes oil loss. The technician may choose to speed up the recovery process by packing the recovery cylinder in ice and or applying heat to the appliance. Let me repeat that again. The technician may choose to speed up the recovery process by packing the recovery cylinder in ice and or applying heat to the appliances. After recovering refrigerant in the liquid phase, any remaining vapor is condensed by the recovery system. After recovering refrigerant in the liquid phase, any remaining vapor is condensed by the recovery system. When servicing a unit that has a receiver/storage tank, place the refrigerant in the receiver. When servicing a unit that has a receiver/storage tank, place refrigerant in the receiver. Okay. Now I got that on here. Let's look at this thing here real quick. Okay. Talk a little bit about chillers real quick too. Then we'll close this out a little bit. Okay, about chillers. Low pressure centrifugal chillers. Okay, replacement refrigerant, safety, handling, and all the stuff like that. R123 performance and capability and handling. The retrofit of R134A into existing equipment. The R12s and planning of the future. The low pressure chillers are used for large installations and range up to 2,000 tons in a single unit. Low pressure chillers typically use as their refrigerants R11, R113, or R123. Oh, well, 123, we'll call it. Larger units over 150 tons of capacity will use R11, while smaller units most often use R113. The AHCFC replacement refrigerant R123 or 123 is an acceptable substitute for the CFC 11 or R11 under the significant new alternative policy SNAP program, abbreviation SNAP. So let's go over this again. So low pressure chillers are used for large installations and range up to 2,000 tons in a single unit. So larger units over 150 tons of capacity will use the R11, while smaller units most often will use that R113. And this AHCFC replacement refrigerant R123 is an acceptable substitute for the R11 under the significant new alternative policy SNAP program. Remember that SNAP program, under the SNAP program. Okay, other replacement refrigerants, including R123, will be analyzed within this section. Okay, centrifugal system configuration. The compressor, the operating principle of a centrifugal refrigerant compressor is very similar to that of a centrifugal liquid pump or centrifugal air moving fan. Through the centrifugal force developed by the impeller wheel, the vapor is forced radically outwards between the narrow walls of the hollow impeller wheel, causing an increased refrigerant density and raising the internal kinetic energy through self-compression. Refrigerant is rapidly discharged from the blade tips into a housing within the compressor's body at an increased density, temperature, and pressure. Okay, lubricants. Some centrifugal compressors are pressure lubricated. Typically, the oil sump and pump as part of the compressor's body. Others, such as hermetically driven, have refrigerant-cooled motors, while open drive units depend on the air or to cool the motors. A condenser. The condenser design is of the shell and tube type, with water being a condensing medium. Through multiple water passes, refrigerant vapor is condensed within the shell. Condenser water is usually pumped to a cooling tower where atmospheric air is passed over the water to remove heat, allowing most of the water to be reused. Okay, float type metering devices. Two types of floats are used. The high side float and the low side float. The high side float regulates refrigerant through the high side float valve to an immediate chamber between the high side float chamber and the low side float chamber. Some vapor is directed to the second stage impeller suction inlet, while the remaining cool refrigerant leaves the immediate chamber into the low side float chamber. From the low side float chamber, liquid refrigerant is metered into the evaporator chiller shell, where heat is transferred from the circular lobe. The evaporator or cooler. The typical evaporator assembly is of the shell tube flooded type, and with refrigerant in the evaporator shell. Secondary refrigerant water is circulated within the closed loop through tubes and pumped out to heat load or air handles. So pressure relief is accomplished by a rupture disc located on top of the evaporator or cooler set to fill at 15 psig. So remember that. The pressure relief is accomplished by a rupture disc located on top of the evaporator or cooler set to fill at 15 psig. So the rupture disc is set to fill at 15 psigs. Okay. Capacity controls. The system capacity control is accomplished at the compressor by one of the combination of the following methods: a suction throttle dampener, hot gas bypass, variable pitch inlet guide vane, variable speed driver turbine, and variable frequency drive. So I'll repeat that again. Capacity control system. We talk about the capacity control. The system capacity control is accomplished at the compressor by one of the combinations of the following methods: 1, the suction throttle damper; 2, the hot gas bypass; 3, variable pitch inlet guide vane; 4, variable speed driver turbine; and 5, variable frequency drive. The purge system. Air and non-condensables tend to rise and collect at the highest point in a system. That location is always within the top section of the shell and the tube condenser, with the condenser located at the highest location of a centrifugal appliance. So let's repeat that again. Air and non-condensables tend to rise and collect at the highest point in the system. That location is always within the top section of the shell and tube condenser, with the condenser located at the highest location of a centrifugal appliance. So that location is always within the top section of the shell and the tube condenser, with the condenser located at the highest location of a centrifugal appliance. Because low pressure systems operate in a vacuum, non-condensables can enter the system through leaks in fittings and gaskets. Auto purge units are used to purge and vent these non-condensables from the top of the system's condenser. The, the pure refrigerant is then returned to the evaporator section. While the EPA allows purge systems to release small amounts of refrigerant along with non-condensables, a purge system that has an increase in running time is a good indication that the refrigerant system has a leak and is taking in non-condensables. If the leak is substantial, EPA requires it repair. Newer high-efficiency purge systems are available that reduce refrigerant emissions by 97%. So, again, while the EPA allows purge systems to release small amounts of refrigerant along with the non-condensables, a purge system that increases in runtime is a good indication that the refrigerant system has a leak and is taking in non-condensables. If the leak is substantial, EPA requires a repair. So if it's substantial, it has to be repaired. Let's keep that in mind. Okay, leak checking. Leak checking low pressure system is done with refrigerant system pressure. Heater, blanket, or circulation of hot water will raise system pressure, and a conventional leak detection method can be used. Pressure in the system should never exceed 10 psig because the rupture disc on the evaporator is set to fill at 15 psig. The rupture disc's discharge line should always be piped to the outdoors. When checking a low pressure system for tube leaks, a hydrostatic test tube kit can be used. Repeat that again. Pressure in the system should never exceed 10 psig because the rupture disc on the evaporator is set to fill at 15 psig. The rupture disc discharge line should always be piped to the outdoors. When checking a low pressure system for tube leaks, a hydrostatic test tube kit can be used. Remove the water and place the leak detector probe at the drain valve to detect leaks. During standard vacuum tests, if the pressure in the system rises from 1 millimeter of mercury to 2.5 millimeters of mercury, the system probably has a leak and should be leak checked. So let me repeat that again. During the standard vacuum test, if the pressure in the system rises from 1 millimeter of mercury to 2.5 millimeters of mercury, the system probably has a leak and should be checked. Okay, refrigerant recovery. Recovery machines have been employed with large centrifugal equipment for many years when there is a need for major service. Refrigerant recovery from a low pressure chiller begins with liquid removal followed by vapor removal. Often recovery will cause the local cold spots to occur in the system. To prevent water from freezing in the system, make sure the system's water pumps, recovery compressor, and recovery condenser water is turned on. Recovery condenser water usually comes from the local water supply. The low pressure chiller recovery unit has a pressure limiting device that should be set for a cutout of 10 psigs. This is because the rupture disc on the recovery vessel for low pressure refrigerant is set to fill at 15 psig. Let's say that again. The recovery, refrigerant recovery from the low pressure chiller begins with the liquid removal followed by the vapor removal. Often recovery will cause the local cold spots to occur in the system. To prevent water from freezing in the system, make sure the system's water pump, recovery compressor, and recovery condenser water is turned on. Recovery condenser water usually comes from the local water supply. The low pressure chiller's recovery unit has a pressure limit device that should be set for a cutout of 10 psig. Okay. Low pressure appliances employ a flooded type of evaporator called a chiller barrel. Due to the convenient vapors and liquid access from the single location in the system. Low side centrifugal low pressure appliances are refrigerant side service through the access valve located at the chiller barrel only. So low pressure appliances employ a flooded type of evaporator called a chiller barrel due to the convenient vapor and liquid access from the single location in the system. Low side centrifugal low pressure appliances are refrigerant side service through an access valve located at the chiller barrel only. Okay, liquid recovery. The liquid recovery is done by using the push-pull method. Is used. Okay, liquid recovery is done by using the push-pull method. A lower pressure is created in the recovery cylinder, which forces the liquid refrigerant from the chiller into the cylinder. So, a lower pressure is created in the recovery cylinder, which forces the liquid refrigerant from the chiller into the cylinder. The pumping rate will increase if the cylinders. The pumping rate will increase if the chiller's pressure is raised to 5 to 10 psi G by raising the water temperature. The rate will also improve if a 3/4 inch or 1 inch connection is used at the chiller. The recovery unit. The chiller, excuse me. So vapor recovery. Once all the liquid has been recovered, the remaining vapor can be extracted with the recovery unit. With the recovery unit. Okay, let's see this here. Okay, yeah. The recovery unit utilizes a water-cooled condenser, which requires approximately 3 GPM of water between 40 degrees Fahrenheit and 75 degrees Fahrenheit. As with liquid recovery, the recovery time is approved if the connection at the chiller changes to 3/4 inch or 1 inch. Okay, the recovery unit utilizes a water-cooled condenser, which requires approximately 3, gallons per minute of water between 40 degrees Fahrenheit and 75 degrees Fahrenheit. Okay. Vapor must be recovered to meet the EPA requirements. The liquid recovery process alone on low pressure chillers does not satisfy the demands of the law. An average 350-ton CFC-11 chiller with a liquid refrigerant recovery will still contain over 100 pounds of R11 vapors at atmospheric pressure. So that means if you collect all the liquid out of the if you recover all the liquid out of the chiller, they'll still have over 100 pounds of R11 as vapor, still from atmospheric pressure alone. A typical R11 chiller has 3 pounds of refrigerant per ton of refrigerant. So a typical R11 chiller has 3 pounds of refrigerant per ton of refrigeration. Excuse me. So 3 pounds of refrigerant per ton of refrigeration. That's R11. Usually after liquid recovery, 10% of the R11 remains as vapor at atmospheric pressure. Assuming a recovery unit has a capability of 29 inches of mercury vacuum, the remaining total charge will be less than 1%, which will meet EPA requirements as shown. Let's see on this chart here. Let's see this chart. Okay. Okay, let's see here. Self-contained recovery systems are available with 3,400 to 5,000 pounds liquid storage capacity. Liquid level indicators are available for all sizes, with some manufacturers offering electrical heaters to recycle and force liquid from the pump out tank to chiller. All directions and guidelines for liquid and vapor recovery methods are to be taken in prescribed stages per direction in the equipment manual. Importance of following safety guidelines and practices cannot be overstressed. Charging. Refrigerant charging is done in the evaporator section. During system charging, refrigerant gas is initially charged into the low pressure chiller before introducing liquid into the chiller barrel to prevent liquid vaporization, therefore preventing water freezing up within the tubes. Do not inject liquid refrigerant during charging until the saturation temperature is above 32 degrees Fahrenheit. So remember that. Refrigerant charging is done in the evaporator section. During system charging, the refrigerant gas is initially charged into the low pressure chiller before introducing liquid into the chiller barrel to prevent liquid vaporization, therefore preventing water freezing within the tubes. So you know, so during the system of charging, the refrigerant gas is initially charged into the low pressure chiller before introducing liquid into the chiller barrel to prevent liquid vaporization, therefore preventing water freeze up within the tubes. Okay, chiller at idle. When low pressure chillers are left idle, there must be a slight positive pressure left on the system. Heating blankets, resisting heaters, or warm water circulation through the chiller are all methods to maintain positive pressure. Now, for safety, OSHA Standard 15 requires the use of room sensors and alarm to detect refrigerant leaks. This standard includes all refrigerant safety groups. Each machine room shall activate an alarm and mechanical ventilation before the refrigerant concentration exceeds the TLV or threshold limit value, and the TWA, the time weight average, the time weighted average. So let's repeat that again. OSHA Standard 15 requires the use of room sensors and alarm to detect refrigerant leaks. The standard includes all refrigerant safety groups. Each machine room shall activate an alarm and mechanical ventilation before the refrigerant concentration exceeds the threshold limit value and the time weighted averages. Every refrigerant system shall be protected with a safety relief device or some other means designed to safely relieve pressure. Pressure relief valves are always installed in parallel, never in series. Always vent to outdoors. Okay, replacement refrigerants. In general, an alternative refrigerant cannot replace an existing refrigerant through any drop-in procedure. Consult the equipment. Okay. The ASHRAE safety rating for R123 is B1. This signifies R123 has evidence of toxicity at concentrations below 400 ppm. Extra precaution and machine room requirements must be observed. Okay, let's see. Okay, R134A. The PAFT-2 program on R134A has been completed. All available results show that the R134A is at least as safe to use as the CFC-12. Ozone depletion potential of HFC on 134A is 0 because it has no chlorine. This removes R134A from the ozone depletion controversy, primarily due to lubrication requirements. It is not a drop-in replacement for R12. Okay, R124. The PAFT-3 program on the HCFC 124 began late in the 1989. No adverse toxicology findings have been reported. According to existing test results, R124 is an environmentally acceptable and functional equivalent replacement for R114. This refrigerant carries OSHA Standard 34 Safety Group classification rating of A1, or A-1. So when it comes to inhalation, are HCFCs and HFCs toxic? They pose no hazard to systematic toxicity or carcinogenicity or mutagenicity or pterogenicity at or below time weighted averages of airborne concentration exposures for full work shifts, 8 or 12 hours. Short-term exposure should not exceed 3 times the assigned exposure limit for more than a total of 30 minutes during work days, provided that the TWA is not exceeded. Under no circumstances should they exceed 5 times the TWA. What are the symptoms of exposure of the AEL? Let's see, cardiac sensations and it says do not treat with adrenaline or similar heart stimulants. An increased risk of cardiac arrhythmia and cardiac arrest will result. Okay, so yeah, don't do that. Okay, let's see here. So you gotta use that breathing apparatus, remember that. Okay. Let's see something else here. Let's see, yeah, we might have to do some more studying another one of these later on. But thanks for sticking around. I'll see you next time.